So let us just discuss completing the square method briefly, though in your level it has little application. Okay, so let us talk about the completing the square method. The completing the square method is actually a very, very direct way of analyzing quadratic equations. And how do I mean by that? It simply is, it shows the roots of quadratic equations. Okay? Now, let us consider the general form of equation. Ax squared plus bx plus c equals 0. If I want to use completing the square method, the first step I will have to do is to take the constant term to the other side of the equality sign. What do I mean? Ax squared plus bx equals 0 minus c. So of course this gives me ax squared plus bx equals minus c. Call this equation 1 and call this equation 2. Now after doing that, the next step is to divide through by the coefficient of x squared so as to make x squared stand alone. What do I mean by that? So just say all over a, and all over a. So, of course, this will cancel out. And I am left with x squared plus bx over a equals minus c over a. So this is the resultant of the division of equation 2 by the coefficient of x squared. So the next thing to do after that is to divide the coefficient of, okay, let me put it this way. Add half of the coefficient of x, square it, and put it to both sides. Let me rephrase my statement again. Find the half of the coefficient of x. Is that okay? Once you have that, square it and add to both sides. What is the half of the coefficient of x? The coefficient of x is what? B over a, right? So if I have half of it, I'm just saying divided by 2. This is also equal to b over a divided by 2 over 1, right? So this will give us b over a times 1 over 2. Of course, this will be equal to b over 2a. So this is the half of the coefficient of x. I said you're going to square it and add it to both sides because we are trying to complete the square of the initial equation that we have. Very simple. And to do that, it is as simple as A, B, C. So we have x squared plus bx over a plus b over 2a all squared equals minus c over a plus b over 2a all squared. And having done that, you would have to pick this guy, right? And this guy over here. Ignore my guy here in the middle. And how do we do that? It is very, very simple. We are going to have x squared plus b over 2a squared equals minus c over a plus, if you open the brackets, we have b squared over 4a squared. And to simplify this further, we can say x plus b over 2a all squared equals minus c over a plus b squared over 4a squared. Now, after doing that, the next thing we have to do is to find the LCM of these right hand side. And how do I find the LCM? Let us ignore the left hand side first. Okay, so we have 4a squared as the LCM. So how many a can we see in 4a squared? Of course, we have 4a. 4a times minus c, we have minus 4ac plus 4a squared goes in 4a squared one time, and we have b squared. Is that okay? So this is what we have. If you now bring back the left hand side, we have x plus b over 2a all squared. Remember that if I want to make sure, my aim is to look for the variable x. Is that okay? So anything that is going to affect or that is going to disturb variable x, I'm going to do away with it as much as possible. And how do I do that? Is to remove every hindrance that is disturbing x from standing alone. And what are those hindrances? The first hindrance is the square that is on top. And the next hindrance is b over 2a. And we can't remove all of them at the same time. So we have to remove them bit by bit. Just like if you want to devour your chicken, the lap of the chicken. The first thing you have to do is to hold the chicken and do what? Tear it bit by bit until you get to the bone. And most people don't just leave the bone like that to rest. They have to break it, and that's what we want to do now. We want to break everything that is making x not to stand alone, so that we have x as a stand-alone variable, and it will give us the value we are looking for. So what do we mean? We have that we have to add square root to both sides. If I do that, I have square root here, and I have square root here. Of course, these two will cancel the square root. Okay? And I'll be left with x plus b over 2a equals the square root of minus 4ac plus b squared over 4a squared. This is still the same thing as x plus b over 2a equals the square root of, if I rearrange this, I have b squared minus 4ac all over the square root of 4a squared. All over square root of 4a squared. And the square root of 4a squared is actually 2a. Okay? So if I do that, I would have x plus b over 2a equals square root of b squared minus 4ac all over 2a. But I would like you to note that since we have the square root crossing to the other side, it becomes plus or minus. Okay? This is plus or minus. We also have plus or minus here. Alright? So we want to make x stand alone, and to do that, we have to bring b over 2a to the other side. And how do we do that? Very, very easy. We have x to be equal to minus b over 2a, okay, plus or minus square root of b squared minus 4ac all over 2a. So if you find the LCM, we have this to be 2a, and this becomes minus b plus or minus square root of b squared minus 4ac all over 2a, which is equal to x. And this serves as our general form of the quadratic formula, which is also called the algebraic formula. So you will realize that the completing the square method is a link to getting our almighty formula or algebraic formula, as the case may be. So this is the algebraic formula. Before we call it a day today, we have less than 10 minutes to go. Before we call it a day,